Student, good morning everyone. So, dear student, in the last class we have discussed about the IPSC nomenclature. So, I hope you have tried some more examples of IPSC nomenclature, right? So, IPSC nomenclature is very important part, like as I said in the last class itself, right? So, dear student, so now today we will move towards the very important part, and that is nature of CX bond. So once if we come to know what is the nature of CX bond in the haloalkane, then definitely one we can see which type of reaction it can undergo. So first of all, let us have nature of CX bond as a heading. Nature of CX bond. That means how it will react and what are the see here, after knowing the conditions and the nature of a haloalkane, one we can say very easily which type of reaction it can undergo, for which type of reaction it can undergo. So that's why, so the nature of CX bond plays a very important role now. So we will go point wise so that you can very easily understand the concept. So in the introduction class itself, I have already given a hint about CX bond. That means in the haloalkane, carbon is having partially positive charge and the halogen is having partially negative charge. Why? Because halogens are more electronegative than what? Carbon. So that's why they drag the bonded pair of electron themselves. So thus the electron density slightly increases even though there is a bond between C and X. Then also what happens? The density of electron increases on the X and the loser will be the C. That means it loses even though there is a bond. So therefore on it will get, that means on the carbon we will get partially positive charge and on the halogen we will get the partially negative charge. I have already explained about this, right? So now in this class we will go point wise. Since halogen atoms are more electronegative, so it is very interesting, right? Since halogen atoms are more electronegative, since halogen atoms are more electronegative than carbon, right? So if we see the haloalkane, this is the just example of haloalkane. If we generally see the haloalkane, then definitely if we compare carbon as well as the halogen is more electronegative, and you already know what the more electronegative element can do, right? We already know that. That means more electronegative element can drag the electron towards itself, which is very important, right? You must and should remember. Why? Because I'm just asking you to thoroughly read about the electronegativity since from first year, right? So how many of you are going on that path? I don't know. But the more electronegative atom, what it will do is it will drag the electron towards itself. So thus in the haloalkane, if we see the total bond of haloalkane, the halogens are more electronegative than the carbon. So that's why it will get partially negative charge and it will get partially positive charge. So now both the charges are present on the same compound. Both the charges, if they are present on the same compound, then such bonds are, halogen atoms are more electronegative than the carbon. Thus, what happens? Because of this process, both the charge, the haloalkane bond is polarized. Polarized is nothing but what? It has dipole, right? So there are two poles. That means the bond of haloalkanes or alkyl halides are polarized. Why? Because of more electronegative, because of presence of more electronegative element, that is halogens, or those are halogens. Because they are present, what happens? The electron will move towards the X, I mean halogen. So thus, what happens? The density of electron increases on the X, and the density of electron decreases on the carbon, because it is losing directly or indirectly. The carbon is going into the loss. So now, just because we are observing both the charges, then the bond is the halogen, I mean the bond present between halogen and the alkyl halide, or alkyl halide, which is polarized. One we can say very easily. The first point is about polarization, right? So it is polarized. Why? Because of presence of more electronegative element, that is halogen, right? So now the next point, second point is, so very important, this point you remember. The carbon atom bears partially positive charge, already we saw, whereas the halogen atom bears partially negative charge. So continuation of first point only, one we can say, because of more electronegativity of X, the dragging of electron takes place. As a result, it will get partially negative charge and it will get partially positive charge. That's why it is polarized. In the first point only I have explained about second point also, right? So we just need to say in the first point that is a polarized. And now in the next point, in the second point, because halogen is more electronegative than the carbon, so what is happening? The electrons are moving towards the what? X, and carbon is going into the loss. So that's why because of this, what happens? Carbon will get partially positive charge and halogen will get partially negative charge on it, right? And the next point, since the size of halogen atom is increases as well as move down to the group periodic table, fluorine atom has the smallest and iodine atom has the largest size. Consequently, the carbon halogen bond length also increases from CF, that means fluorine, to iodine, right? So I will give a very clear idea about this point. That means the third point. So now what happens? See here, size plays a very important role. So if we see the 17th group, fluorine, chlorine, bromine and iodine, as we move down the group in the periodic table, what is happening, right? What is happening? The size is increasing. We already know the atomic size increases in the group. So in the same way, what is happening? As we move from fluorine to chlorine, size increases. From chlorine to bromine, again the size increases. From bromine to iodine, again the size will increases. So what is happening? So see here, what we are seeing with the carbon only X. What if iodine is present with the carbon? That means alkyl group. What if bromine is present with the, what is there any difference? Yes, of course, there is a difference. So that means many type of example you will get in your competitive examinations based on these concepts, right? So what happens is, I will write the bonds CF, CCl, CBr and Ci. That means the alkyl halide with fluorine, with chlorine, with bromine and with the iodine. So as the size increases, right? As the size increases, what happens? Bond length also goes on increases. Very important. So if, see here, if the bond length, the bond between the two atoms is nothing but the bond length. So if the bond length increases, if it increases, so that means here the bond length, the least size is of fluorine and the most highest size is of iodine. So that means Fluorine is having a less size than what? Chlorine. Chlorine is having less size than what? Bromine. And bromine has a less size than what? Iodine. So that means iodine, if with the alkyl group iodine is present, then the size of that molecule will be very big. Why? Because the size of iodine. And as the size increases, the bond length is also increases. As the bond length increases, the strength decreases. Right? This is organic chemistry. Right? See, now what happens is, as the size between carbon and alkyl group and halogen group increases, what happens? The molecule will move away and away from the carbon, and the bond size. So that means the bond present between the carbon as well as the halogen, the size goes on increases. See, imagine I will give you two sticks, right? So this one stick size is this much. That means the only black part, and one more stick size is this much. That means white part. Which stick will break very easily? Can you imagine? Right. So the small sized, that means stick will not break very easily. Why? Why? Because we don't have sufficient space to remove or to break. But here we will get more space to break it. In the same way, in the organic compounds, so what is the next point is, as the size increases, as the size of halogen increases like this, from already we know from in group, if we move from top to bottom, then definitely the size of halogen increases. As the size increases, what happens is the bond length will also goes on increases, right? This is the third point. As the size of halogen increases, the bond length will also goes on increases. And further, if I move in the depth, then as the size increases, the bond strength decreases. So that means if I ask you, among these all, I mean fluorine to iodine, which alkyl halide can very easily undergo into the break, then your answer should be this. Why? Because iodine has more size as compared to bromine, chlorine and fluorine. So that means the bond length is also very big. So if it is, if the bond length is more, then definitely we can very easily remove that bond between this iodine as well as the carbon. But as we move back, like bromine, chlorine and fluorine, the size goes on decreases. As the size decreases, bond length also decreases, right? But bond strength increases. We cannot easily remove the bond between these two, right? And as the bond length increases, bond enthalpy decreases. So that means bond enthalpy, that means the energy required to break a bond, as I said already, right? So as the bond length increases, bond enthalpy decreases, right? Very easily we can remove the bond between these two, as compared to bromine, as compared to chlorine, as well as this fluorine. That means fluorine has highest boiling point, we can say, right? These are very confusing. I don't want to take you in the confusion. So when we come to the later, I mean in the competitive part, then definitely we will be having in very detail, right, these concepts. But now nature of bond already we saw. Because of in CX bond, definitely there will be a presence of halogen. Halogen is more electronegative than the carbon, so that's why the bond between carbon and halogen is polarized, one point. And now the next point is, the carbon will get the partially positive charge and halogen will get the partially negative charge. Why? Because of presence of more electronegative halogen. So because of presence of more electronegative halogen, the electron move towards the what? Halogen itself. As a result, it will get partially negative charge and carbon will get partially positive charge. Coming to the third point, which is based on the size. As the size increases, bond length also goes on increases, right? And the finally, as the bond length increases, bond enthalpy, that means bond energy, decreases. So these are the some basics things about what are that means haloalkane. So now we will see the methods of preparation. How one we can prepare a haloalkane, right? So preparation will also very important part in our examination. The question will be asked based on the preparation itself. So methods of preparation. So we will see what are the methods of preparation. So that means how these haloalkanes can be prepared. So the first method will be from alcohol. So alcohol means there must be a presence of what? OH group. There must be a presence of what? OH group. That is nothing but what? Alcohols. So alcohols when warmed with the hydrogen halide, that means hydrogen chloride in the presence of ZnCl2, right, as a dehydrating agent. So that means water molecule will be removed. Or else, see here, very simple reaction. Take one alcohol, right, in the presence of with hydrochloric acid in the presence of ZnCl2. In the presence of ZnCl2, this is called Lucas reagent. And ZnCl2, what it will do is it will help in the dehydration. Dehydration is nothing but what? D means remove, hydration means water, removal of water molecule. ZnCl2 acts as a removal of water molecules. As a result, so if I remove simply the water molecule in this compound, then removal of water molecule, loss of water molecule, negative. So now water, if we remove a water molecule, what are left? R and Cl. You just write down R, Cl plus what we have removed? Water molecule. What we are preparing? We are preparing haloalkanes. What is the compound of this? Haloalkane. Alkane as well as the halogen. So very simple type from alcohol. So I repeat, primary alcohol you can take, secondary alcohol you can take, right? Whatever it may be. So alcohol reacts with hydrogen chloride or hydrogen halide in the presence of ZnCl2, acts as dehydrating agent. That means ZnCl2 will remove water molecule to form what? Haloalkane. So simply you remove the water molecule. Whenever there is a ZnCl2, remember there will be a dehydration as well as alcoholic potassium hydroxide. But here in this case, they have not used alcoholic potassium hydroxide. Instead of that, we are seeing the reaction with the ZnCl2, right? So these two, that means these are some hints, right? So how to remember and how to produce the product from the different examples. So don't let or don't just depend on the examples whatever I have I will give in the right classes. Please go through the books also, right? Very important. And one more we will see by alkanes, right? This is also very simple. Second method, by alkanes. By taking alkanes, one we can prepare a alcohol by alkanes. So alkanes reacts with halogen in the presence of sunlight. Alkanes reacts with halogen in the presence of sunlight. So we are just heating the alkanes in the presence of what? Sunlight. What happens here? Just you just replace. So that means if I write the open structure CH2H, if I write this as like this, then it will be like this. So now you just remove this what happens? RCH2 instead of H, what will come? X, and what we are remove? Hydrogen halide, right? Like how one we can prepare by alkanes, right? So alkanes are treated with, halogens in the presence of sunlight. It forms haloalkane, right? So this is one more example. So with this we will conclude. In the next class we will see some more preparation, right? Thank you.